As I said, I'm Doug Stevenson. I'm a developer advocate with the Firebase team. I've been using Firebase since it became a platform, so I like it a lot. Also, what I like a lot is Android things, because I'm a long-time Android developer. I've been doing Android since the very first Android phone, the HTC G1. Does anyone know that phone? Oh, that's the same people. Yeah, so what got me into Android in the first place. Is this phone. I found it kind of interesting to program for the thing that I hold in my pocket. It's a very personal, very intimate device, right? You depend on it all the time, use it with you all the time. So I know a lot about Android. And that's why I was excited to find out that Android Things was released as Google's Internet of Things platform. So Android Things runs Android, obviously. It's kind of a fork. It's very similar to Android. If you're already familiar with Android development, you already know most of what you need to know for Android Things, because when you build an app for Android Things, you're actually just building an Android APK, and you put it on the device just like you would a normal Android APK. But what's different about it is that you now have access to kind of infinite amounts of hardware. So this is the device kit that some of you probably already have. They were giving them away at Google I/O. They were very common. It's the IMX7. It's called a system on a module. So all of the parts of the like the computation and all the hardware and video stuff is sitting right here on a system board. You can kind of think of it like a little phone that has breakout ports. So it has Ethernet and Wi-Fi. And, the important thing to note here is that there's these 40-pin expansion headers at the top. With these 40-pin expansion headers, what you can do is plug in peripherals. This is the key feature of Android Things, is these peripherals. And there's one peripheral, and this is for development only. This is called a rainbow hat. The rainbow hat kind of seats on top of those 40 pins, and it provides access to things like LCD display, 3 little buttons. You see A, B, and C there, pressure temperature sensors, multicolor LEDs. You can control all of these things within your Android app. Now, what I just showed you, the system on a module and this rainbow hat, you don't actually ship an Android Things device to customers with these. These are for like testing only. These are for playing around with Android Things, kind of experimenting. You can also put like a breadboard up to this, you know, those little white things with all the pins. So you can play around with all kinds of different hardware and control them from your Android app. Now, I'm actually not much of a hardware guy. I'm a software guy. In fact, I'm a systems guy. I like to push data around the internet. That's kind of what I do, and Firebase is very good at that. But when it comes to hardware, I get kind of intimidated. In fact, there's all of these different kinds of peripheral I/O you can do. So, and I won't go through them in detail, but you have something called GPIO, which is basically on-off switches, so LEDs and buttons. You have pulse width modulation, which is like audio. Then it gets even crazier where you have synchronous and asynchronous buses. You also have things like things that do like over USB, or anything where you're doing like bidirectional communication with various peripherals. Now that's where things start to break down for me. I like the idea of putting peripherals on my computer, on my devices. I don't like the idea of having to like deal with the hardware and writing drivers, but that's okay because Android Things comes with drivers. Well, at least the devices I showed you come with drivers. So that rainbow hat has a driver. And all of the buttons and all of the different peripherals that are attached to it all have their own drivers. So if you want to control them, you're just writing Java or Kotlin code. And I'll show you Kotlin because Kotlin, right? Who's using Kotlin instead of Android or instead of Java? Okay, handful, right? I recommend using Kotlin. It's a very fine language. So when everything is set up, it looks something like this. This is what the thing looks like on my desk. This is kind of an older version. The newer ones come in these cardboard enclosures, so you can set it up kind of like a little video game machine. But this is what I have on my desk. And you can see the Wi-Fi antenna sticking out. There's a camera coming out the left there. There's a touch screen that's popped out through some pins. The touch screen makes it look just like a phone, right? You can touch things just like you would on your phone. But not all Android Things have a display. Some Android Things are much more complicated. So I don't know what this guy's doing here. It's kind of intimidating. Like I said, I'm not a hardware guy, but if you are a hardware person, you can build your own hardware and then deploy Android Things on top of it and write code to run that. But the Internet of Things is what I'm interested in. writing code that uses internet features like FTP and HTTP and doing raw sockets for a long time. I love getting things connected. One of the first things I ever did on the web was write a chat server because I like being connected. I like the idea that all these things are connected. So with Android things, the idea is all of your stuff should be connected. Your Android things should be talking to each other, right? What's the point of having an Android thing, an Internet of Thing device that's not connected to the internet? So they should be talking to each other. You might have a companion app too. So you have things talking to each other and they're talking to a companion app. The question is, how do you get these things talking to each other? Well, if you're doing direct communication like I'm showing here, really your only option is Bluetooth, right? Or some other wire, maybe like an open Wi-Fi. But this requires all the devices to be in proximity with each other. And we know nowadays that mobile devices are in fact mobile. Your Internet of Things device could be mobile. They could be anywhere, so they should be connected through the internet. So how do you get these things connected? Well, one way is through Firebase. So if Firebase kind of sits in the middle of all of your communications, it makes it really easy to have your devices talking to each other. You don't have to worry about Bluetooth. You don't have to worry about Wi-Fi. You just use Firebase. Firebase becomes sort of the central hub of all your communications. For those of you who don't know what Firebase is, it's Google's mobile application development platform. It targets Android, iOS, web, and on top of that, also Unity games and C++ games. So there's client libraries to access Firebase from all those platforms. Now you might be wondering, well, how does Android Things get a hold of Firebase? Well, Android Things, well, let me back up. Firebase is distributed for Android through Play Services. So Google Play Services has a bunch of APIs, and Firebase is included with that. Android Things also has Play Services in it. So Android Things 1.0, which was just released, I believe, has, was it the Android, or the Play Services APK 12.5.11 or something like that. All that's to say is you can use Play Services APIs in your Android Things, which means you can use Firebase with them. And there's a lot to use in Firebase. So in fact, this diagram is a little bit old. There's one more thing here that's missing, but there's a lot of components. But some of them don't really make sense to use in Android Things. The only things that are available right now are the ones that are highlighted in green. So real-time database, Firestore, authentication, cloud storage, and so on. Most of these things are what we would consider to be in the build pillar, or develop pillar. So if you're building an application, you're building some core functionality, these are the features you would use. But one of these features is not client-driven. All of them are client-driven except for one, and that's Cloud Functions for Firebase. It's kind of the opposite. With Cloud Functions, you're writing backend code, and you're writing it in JavaScript, or in my case, TypeScript, because I like strongly typed languages. And it runs in a managed Node.js environment. So what you do is you write code, you deploy it to Cloud Functions, and it runs in response to events in your project. And if you're writing HTTP triggers, so you can create like a web API, that's all driven through Express.js. So if you're already familiar with Node, and you're already familiar with Express, you already know a lot of what there is to know about Cloud Functions. Now, you might be wondering, well, I built something with I built something with Firebase. I built something with Android Things. What did I build? Well, I built something that uses a bunch of features. So I used Firebase Auth to get users logged in. I used Cloud Firestore for data storage. So Cloud Firestore is kind of a NoSQL cloud-hosted database. So I'll talk more about that later. Cloud storage is cloud-hosted file storage. So it's really good at storing things like images that users might upload or any sort of large binary data. I also use Firebase Cloud Messaging to send notifications between devices, which is important because devices may go into deep sleep, and what you can do with FCM is ping devices, get them to wake up, and have them run some code. I also use Cloud Functions, which I'll talk about later, and you can use Crashlytics for crash reporting. So all of these products work together in tandem to build your Android Things. Now, you might be wondering, what did I build? Well, I built a doorbell. Why would anyone want to build a doorbell? It's really simple, right? The guest comes up to the house, pushes the doorbell, the host knows, they hear a ring, and they go into the door. Could we make that any better? I mean, it's already pretty simple. In fact, you can't make it any simpler. You can only actually make it more complicated. It turns out there are, and I didn't know this when I started my project back in November, but it turns out there are other doorbell systems out there. So I discovered there's a company called Ring that does these video doorbells. Also Nest, which is owned by Google, has a video doorbell, and I think there's other ones on the market. So when I was building this, I didn't realize I was kind of not really disrupting the doorbell market. The doorbell market had already been disrupted. I was just building something that kind of duplicated it, but I had fun with it. So the way my video doorbell works is, first the guest approaches the home, they ring the doorbell. Now that's a classic doorbell. Imagine a digital doorbell or something with a fancy button, not an old school button. And what it'll do is it'll take your picture. So the idea is that the homeowner then gets a notification saying, who's at the door? Well, you can see for yourself. You don't have to guess. You can know from anywhere. And then if the homeowner decides to let you in, they can do it right there with a touch of a button and unlock the door. Now if you're using a rusty padlock to secure your home, you should consider an upgrade to something a little bit better. But the idea is the Android thing is sitting here managing the press of the button, the taking of the picture, the notification on the companion app, and also unlocking the door through whatever device is hooked up to it. Now how do you build something like this with Firebase? Well, this is the complete system diagram right here. There's a lot going on here. You can see Firebase is used throughout. I'm going to break this down step by step so you can see how data flows from an Android thing to your app and then back to the Android thing. So the first thing to do, obviously, is to just take a picture, right? That's the first step. Actually, the first step is to receive a button push, right? And I'm not going to insult your intelligence by showing you how to make a button and push it. Like, that's pretty simple. You can download my sample code. I'll show a link on GitHub at the end. But the idea is, first thing you want to do is capture a picture. Now, capturing a picture is pretty straightforward. If you're an Android developer and you know the Camera 2 API, it's the exact same API. It's all still Android. So if you have camera code, you can reuse it. But, and that link up there goes to the official Camera 2 APIs that the Android team has provided. But when I plugged that into Android things, I discovered that I had a couple problems. First of all, the camera preview renders to something called a texture view. Texture view is a way of sending OpenGL textures to display on the screen. But it's slow on my Android things device. I kind of try to figure out why is it so slow. This is almost unusable. I want to show a preview on the LCD right there as the guest is taking their picture. So you've got to be able to square up for yourself here, right? You want to see a preview. Well, the reason why it's slow is because Android things don't have a GPU. In order to do OpenGL texture mapping, a GPU is really required to do all the little tiny calculations of triangles and blast into the screen. But without a GPU, you have to do it in the CPU, and that's just really, really slow. So I had to port it to Surface View instead. So an Android Surface View is just raw drawing pixels on a view, like blasting pixels repeatedly. This is much faster because it doesn't require computation. It doesn't require a GPU just to calculate pixels and blast into the screen. So I had to port that. I also had to remove the code that dealt with autofocus. So the sample code that I'm linking to assumes that the device has autofocus. And pretty much every consumer phone has autofocus, right? So the idea is it can sense where the target is to adjust the focus so that it's always clear. But the camera that comes with my Android Things kit does not have autofocus on it. Without GPU, without autofocus, you think, well, how useful is it? Well, it's useful because it's cheap. Without a GPU, it's cheap. Without autofocus, it's cheap. And that's good. You want your Android things to be cheap and affordable. So I had to remove the code that dealt with autofocus. And it's a state machine internally, so I just ripped out that state. In the best case, you have code that's portable that detects if there's autofocus and uses it, else not. I'm lazy, so I just ripped out all the autofocus code. So after that, you capture a picture, you save it to the device. Now what do you do with it? Well, what I did is I chose to upload it to cloud storage. So I'm using the cloud storage SDK for Firebase to upload directly to cloud storage. And this is what the code looks like. So I have a method here. Again, this is Kotlin, not Java. You could write it in Java if you want. So I have a method called upload file, and it receives a file. And what I'm going to do is format a date. And that date is going to become the unique ID for this ring. So this represents a ring. I'm going to build a path to cloud storage with it. So under /pictures/ whatever the current date is, .jpeg, that becomes the path in cloud storage where the file is going to live. And then I'll use the cloud storage SDK. There's a singleton instance, and I'm going to build a reference to that path. Now, a reference itself doesn't do anything. It's just like a pointer. It's like a symlink right into cloud storage. And with that reference, all I'm going to do is call put file on it and hand it the file that I just found, or that I just captured. That's it. That's the only line of code that it takes to actually upload this file. The SDK is doing all the heavy lifting for you. In fact, there's a lot going on here that you can't even see. What it's doing is it's actually retrying in the case of a failure, so it's robust. It's not going to give up very quickly. It's also going to resume in the case that if a transfer gets cut off. So you have a very, very robust SDK doing a lot of work for you, but all you do is write this one line of code. Okay, so after the picture is uploaded, it's going to end up in cloud storage. And this is a screenshot of the Firebase console looking at a cloud storage bucket that's attached to the project. And so you can see here, there's a bunch of files, they're all JPEGs. I have a very terrible preview image right here. That's like a picture of the ceiling of my basement office. That's not very exciting. But the point is, each one of these rings becomes a file in cloud storage. So we have something that looks like this. We're far from complete. What do we need to do? Well, we need to get that image onto the user device, or onto the homeowner's device. So what I'm going to do here is use Cloud Functions for Firebase to write a trigger that automatically responds to that file upload. So when that file lands in cloud storage and the upload is complete, I can have some code in Cloud Functions running that gets triggered immediately, and I'll do something with it. And what do I do with it? Well, I'll write some metadata about that to Cloud Firestore. So on the one hand, we have cloud storage, which is blob data, it's a file blob, and then we have Firestore, which is more of the metadata. It's easily indexed and easily searchable, and I'll show you more about that in a bit. So now we're going to switch into TypeScript world. So this is Cloud Functions code running on a scalable backend that's responding to storage uploads. So I'll break down what this code is doing. I'm defining a new function called onRing. I'm going to export it. That's just what is required for Cloud Functions code. So I'm using the Functions SDK. I'm telling it I'm interested in storage events. Then when an object becomes updated, becomes finalized, and finalized is just the fancy word for storage upload complete. So when a storage upload is complete, I want it to invoke my function called _onRing. And _onRing will get invoked. It receives one parameter, which is object metadata. And this describes the file that was uploaded to cloud storage. It doesn't contain the file, it just describes it. And it's going to return a promise that resolves when all the work is complete. So if you know asynchronous programming in JavaScript, promises are everywhere, right? Promises are kind of like tasks in Android, if you're familiar with the Android APIs. Or if you're familiar with futures in Java programming. It's the same sort of thing. It represents some bit of work that is pending and will complete. So the first thing I'll do is pull the path of the file out of the object, and then strip out the ID of it. So the ID of it, remember, is that formatted data. It's supposed to be unique. Then what I'm going to do is build a ring object. And again, in TypeScript, this is strongly typed. I'm building a ring type object. I'm not just doing some, duck-typed JavaScript object. I like strongly typed languages, so I'm using a strongly typed ring object here. I'm going to give it the ID, the current date, and the path to storage. I'm going to write that to Firestore. So that's all you have to do to write to Firestore. So what's going on here is this last line says firestore.collection. So I'm reaching into a collection called rings, and then I'm creating a document in there, and I'm setting that ring object, putting that ring object into a new document. Now you might be wondering, what are these collections? What are these documents? Well, Firestore has kind of a peculiar way of making you organize your data. So this is what it looks like in the Firebase console when you're dealing with Firestore. So on the far left, I'll read this from left to right. On the far left, there's a collection called rings. Every document in Firestore must live in a collection. You cannot not have a collection. You must have a collection. Now, in the middle column, here's a list of all the IDs in that collection. You can see these are the formatted dates, and there's a document for each one of the rings that I have. And on the left on the right is a list of the fields. So remember that ring object I put in there, it has an ID, it has a date, and it has a path. So now this is the state of the system. I have a file in storage. I've triggered on that upload, and I've written something to Cloud Firestore. But we still haven't even reached the homeowner's device yet. We've got to get that over to the homeowner's device. So the function is going to do a second thing. It's going to use cloud messaging to ping that device. It's going to send the message over there. So we're back in TypeScript world now. We're still in that storage upload trigger, and this is what we're going to do next. So next I'm going to build a payload that describes the cloud message to send. There's two parts to this. There's a notification section, and then there's a data section. The notification section describes what I want a notification to look like. So in Android, there's a notification curtain, and something will appear in there with some text, and you can click it. Now the important thing to note here is click action. Click action is a very special string here. This is actually an action defined in an activity in my app. So if you know how activities work in Android, you can identify what actions they respond to. So when the user sees this notification and they click on that notification, it will launch this activity right away. There's also a data payload here. In the data payload, I'm storing the unique ID, so I know which ring we're actually responding to. And then I'm going to use the FCM SDK to send to a topic. Now, FCM has direct-to-device messaging and also topic messaging. I'm using topic messaging because maybe there's multiple homeowners and they all use the app and they all want to be notified about the ring. So what I'm going to do is send to a topic that all of the apps will listen to. So they're all listening to a topic called rings. I'll send the payload to that topic, and then they'll get notified. Okay, so here's where we're at. Cloud messaging is going to notify the homeowner app. Now, we've gone one direction. We've gone from Android thing up to cloud storage to Cloud Firestore or messaging to notify the app. Now, the app needs to do something with this incoming message. It turns out there are two cases for cloud messaging. The first is, it's going to check, is the app in the background? Meaning, is it completely invisible, or is it not even running? If the app is in the background, what it's going to do is show that notification. When the notification is clicked, that ring ID is going to get delivered to that activity I was telling you about. And then it can display a UI saying, should we let this person in or not? If the app is not in the background, meaning it has a visible activity on screen, instead, it's not going to show a notification for you, but it's going to invoke an Android service. And that service is going to have a method in there that gets delivered a payload that describes the message that was sent. And then in there, I can do the same thing basically, which is launch the UI. So you have two possible paths here. You have to handle both of them. Actually, you don't have to handle the top one. The top one is fully automatic. You don't write any code for that. The bottom one is not automatic. You have to do a simple, just a service. And I'll show you what that looks like. So on the app side, ahead of time, it had to have subscribed to that the rings topic. So what I'm going to do here is subclass Firebase instance ID service. This service is doing a lot of the heavy lifting for you, but there's one method in here called onTokenRefresh. And that's an indication to you saying, Firebase Cloud Messaging is initialized, what do you want to do first? Well, what I want to do first really is just subscribe to that rings topic, and that's it. And now whenever a cloud message is sent to my app, it will invoke a different service. And that other service subclass is Firebase Messaging Service. This is the thing where I actually receive those incoming messages. So on message received will get invoked, it'll get delivered an object that describes the message that came in. And what I want to do really is just get that ring ID out of there. It's the only piece of information that's in there, and it's the only one I'm interested in. Then with that ring ID, I'm going to create a new intent that'll launch my activity, put the ring ID in there, and then start that activity. And that's it. That's all I have to do. So when a message comes in, I just want to start an activity. Pretty straightforward. Now, inside the activity itself, what we can do in onCreate is grab a hold of that intent that launched us, and then pull the ring ID out of it. This is a lot of boilerplate here, but basically what we're saying is, when that message comes in, my activity is going to get launched, and I'll have that ID. Now, what do I do with that ID? Well, let me show you what Firestore looks again. So this is just to remind you, there's a collection called rings, there's documents with IDs, and there's fields within those documents. What I want to do is take that ring ID, pull the document out of it, and show something like this. I want something to let me, as a homeowner, decide if someone should come in. Now, I wouldn't let this guy in. He looks pretty suspicious. So what we need to do is respond to the button press. And again, I won't insult your intelligence by showing you the button press, but we do need to send this message back to the Android thing to figure out what should we do. Should we let them in? What should we show them? So we have to round trip all the way back to the Android thing. Actually, first we have to, I missed a step. So the first thing we have to do is with that ring ID, I have to read the metadata out of Cloud Firestore. So with that ID, I can query the collection, I can get the document, and now I know the image path. With the image path, I can pull that out of cloud storage. When I've pulled that image out of cloud storage, then I can render the UI. So here's what it looks like to fetch that ring data from Firestore. So imagine I have a method called populate views, and it takes a ring ID as the parameter. What I can do is reach into Firestore, into the rings collection, into the document that describes the ring that just happened, and then I'll get it. Get returns a task. This is asynchronous. So on that task, I can listen to see if it was successful. And if it is, I get a snapshot of that document that's in Firestore. With that document, what I can do is convert that to an object. So Firestore on Android has a really nifty way of automatically mapping document fields to actual Java objects. So I have another Java object called ring, and it's going to map those three fields directly into that ring object. Then with the image path that comes with it, I'm going to reach into Firebase storage. I'm going to use Glide to load that image into an image view. Who knows Glide? Okay, a couple of people. So Glide is a library that is very, very good at finding images and loading them in image views. That's all it does, which is actually a lot of work, and it's hard to do right, but it does it very, very well. But you might be wondering, for those of you who do know Glide, how is it able to just load some cloud storage reference into an image view? It seems like, how do you get from that one point to another? Well, it turns out that with Glide, there's a module that's provided by a library called Firebase Ui. And what it's doing is it will insert one of these. Well, actually, you have to insert this, but there's an annotation here for this class called glide module. So this tells your build system, this is a special class. It's going to try to register something that knows how to convert storage references into an input stream. So what's the connection there? You have a storage reference. You know where something lives in cloud storage, and I want to be able to get a hold of that. Well, this is the only piece of code you have to write. You're basically saying, I want what is it called? I want Firebase Image Loader, a separate class, to handle all of that work. Now this is provided for you. There's an open source library called Firebase Ui out there. It provides this Firebase Image Loader. It's automatically going to reach into cloud storage, download the file, and put it into the imagery for you. You don't write any of that code. All you do is write this little connector. That's it. It's a few lines of code. So with that connector in place, and with Glide working, now we've completed the loop between receiving the message and then pulling that data and displaying it in the UI. So we still have to get back to the device. So what I'm going to do to get back to the Android thing is I'm going to write something into Cloud Firestore. I want to write a disposition, so that yes or that no in the UI. If they say yes, I obviously want to let them in. If they say no, I want to display something that says, I don't trust you, go away. So I'm going to write that disposition into Cloud Firestore in the same document that I created earlier. So now we're back into, we're back in Kotlin code. So what I'm going to do is get that disposition, so some true or false based on my button click. And I'm going to reach into the same reference to the same document and update it. And I'm going to update it with two values. The UID of whoever it is that made the decision. So that's a Firebase Authentication user ID. And the actual disposition Boolean itself. That's it. I'm updating that document with these two new values. Then, in Firestore, what we have is something like this. So you can see there's new fields in here. There's an answer object with two new subfields in it, the disposition and the UID. So here's what we have. We have Cloud Firestore receiving this data, but we still have to get that data into the Android thing. How do we do that? Well, there's another Cloud function sitting there that responds to the write to Cloud Firestore. So this is pushing, think of Cloud Functions as like propelling the data into the client. So in Cloud Firestore, what we're going to do is use Cloud Messaging again to send a notification to the Android thing. Now what does that look like? Well, now we need to jump back into TypeScript code running in Cloud Functions. So in TypeScript, what we're going to do is define another new function called onAnswer. And I'm saying, hey, functions SDK, I'm interested in Firestore. I'm interested in documents that match this path. So those curly braces there are matching any document within the rings collection. So anytime any document in the rings collection is updated, I want it to run my function. My function is going to receive a change object, and that change object is parameterized by a document snapshot. A document snapshot is just the description of the contents of that document. And it's going to return a promise that resolves when all the work is done. So what I'm going to do is use this change object. This change object has two fields, a before and an after. So when a document is updated, we have a snapshot containing the contents of the document before the change and the contents of the document after the change. I need to look at that and see if it changed in the way that I'm interested in. So we're going to get the ring ID, we're going to look at the previous value, we're going to look at the current value, and then we have to figure out, basically this line of code says, if an answer was just added to that document, that's the only change I'm interested in. If that answer was added, I want to go on. If nothing was added, if it was a different change, just bail. This code is just bailing if there's any other change. But if it was an interesting change, if the answer's there, I'm going to again use FCM to build a payload. This payload is just a data payload. There's no notification part, it's just a data payload. With the disposition that true or false, it has to be a string, and also the ring ID. So we're beating back to the thing the same ring ID that it originally fed us. Then I'll use FCM to send to a different topic. So we use the rings topic to notify the app. Now I'm using the answers topic to notify the Android thing. So we don't really need topic messaging here. It might be more appropriate to do direct messaging, but it's more work and I'm lazy, and so I use topic messaging again. That's it. That's all the code that's needed in this function. So now what we have is a cloud function that's responding to a change in Firestore, that's sending a cloud message that's going to notify the Android thing. Now, on the Android thing side, we have to do like we did in the client app side and register to receive messages. And here's a bit of code for that. Actually, it's the exact same bit of code you saw on the app side, except it's paying attention to the answers topic, not the rings topic. So again, And this underscores, if you already know Android development and you already know Firebase for mobile apps, you know it for Android things. It's the same code, it's the same darn thing. It's so easy to get started. That's why I love doing this project, because I didn't have to learn very much new stuff. I just start working with new hardware. All right, so to handle the message, again, it's the same thing. You subclass the Firebase messaging service. I'm going to look inside the payload, and I want that disposition. I want that true or false. I want to know, should I, the Android thing has to make a decision. Should I let them in or not? So again, we're going to stick that into an intent, and then start the activity. So because my Android thing has a display, it can display activities. So now we've completed the loop. Now you might be wondering, okay, well what's the user experience on the app side? Like the app side, is it just that yes or no? Well, it turns out I have a little record of rings here. So those of you who know Android development, you know recycle review, right? This is a recycle review. But it's kind of a pain to deal with recycle review because you have to map all these data into all these different views, and you have to do it repeatedly. A lot of that boilerplate work has been done for you in a class called Firestore Recycler Adapter. It's part of that Firebase UI library I mentioned before. Firebase UI is doing a ton of extra work for you. It's basically managing most of the hard stuff with this recycler review. So if you're using Firebase, you're using Firestore and cloud storage, definitely use Firebase UI as well. It's going to handle a lot of that extra work for you. Okay, so that's basically how things work. We've gone from we've gone from thing to device and device back to thing. But what about security, right? This is your home, you've got locked doors for a reason, right? Is Android thing secure? Is Firebase secure? You have to ask yourself that question. Because what if someone were to get into your project and start manipulating data and getting Cloud Functions to execute and sort of figuring out a way to unlock your door without your permission? That would be terrible. You should think about that. You notice that there's entry points here. The entry point from the thing is writing into cloud storage. The entry point for the device is writing into Cloud Firestore. So you need to secure those entry points. The cloud storage security rules can help you figure out who can read and write cloud storage. Now, to get started, and this is what I always do, and this is a terrible, terrible habit, is I set read and write to true. This means everyone can read and write your cloud storage, which is really easy to get started because you don't have to worry about authentication, but it's super insecure. Anyone who knows the name of your project can now read and write your cloud storage. So you should not do this. If you're going to ship anything at all, you should always use security rules to gate who can read and write. At minimum, you should only let authenticating users read and write your database. Same thing in Firestore. Firestore, to get started, sometimes I just say read and write true. Everyone can read and write Firestore. But again, don't do this. This is terrible. You should always be thinking about security rules. And again, what I did in my project was minimally require an authenticated user to read and write data. So, what to do about security? Yeah, it's easy to get started without thinking about it, but minimally all reads and writes should go through authentication. You should also consider data validation rules. So not just who can read and write your data, but what data can get written into your database or into file storage. You can place further constraints on the data that's being written so that only the data that's valid for your app can actually be written. You can learn more about storage and Firestore rules and things like this. The other thing to pay attention to is authentication, right? If you're going to require authenticated users to only read and write your database, you have to manage authentication somehow. Writing authentication login flow is super boring. It's super hard. It turns out Firebase UI handles that for you. So Firebase UI is handling a lot of stuff for you. And in fact, it made this project very easy. I could just focus on the logic of the app and not worry about a lot of the UI. So when you pull Firebase UI into your app, it's just this one line to pull it in. Now what I can do is, in my activity, when there's a login button, all I'm going to do is start an activity and configure an intent for that activity that allows Google sign-in. That's it. This kicks off a whole new activity flow that manages all the login, all of the selecting user accounts, selecting passwords. It does all that hard work. So you can see that there's a button, there's a click listener, we're starting an activity for a result, so we're expecting a result when the UI flow finishes. The UI looks something like this, where you can select from the accounts that are added on the machine. Then when the authentication completes, you have an on-activity result callback, and all you have to do is look and see, is the response indicating success? And that's it. That's all you've done. You write no UI, you write no authentication flows. It's all managed for you. So doing this in the phone app was super easy, right? When you're doing handset apps, you can assume that the user has, an account, They're logged in, maybe they're using Google, they're using Facebook, they're using Twitter, they're using GitHub, it doesn't matter, it's all handled for you. But how do you get the thing signed in? The Android thing has to be signed in somehow. But the problem is, the various UI providers are not available on Android. So you can't just require a user to have a Facebook login on your Android thing. That's kind of silly. Furthermore, your Android thing may not even have a screen. It may be just like a wearable. It might just have a digital display. You can't authenticate on a digital display, let's be honest. You just can't enter a username and password that way. So we need another way. You can do anonymous login, but that's not really what anonymous login is for. Anonymous login doesn't require a username or password, but it's not really appropriate for Android things. Anonymous login is for when you want users to have a frictionless sign-up process and not require them to log in until they've chosen to give you credentials. So you can upgrade an anonymous account to a full account, but again, it's not really appropriate for Android things. So it's best to get proper user credentials for a real login. So how do you do that? How do you get proper user credentials on an Android thing that has very limited capabilities? Well, one thing is to require a login in your app, then send an ID token, a Firebase Authentication ID token to the Android thing so it can then read and write Firebase. So you're basically granting the Android thing permission to act as if it's you, however you log into your app. But how? I mean, the whole point of having Firebase in the middle is that you don't have to talk between the devices themselves. Right? Firebase is the middle, it's the communication point. But if the thing isn't authenticated and your database is locked down, how do you communicate between them? Well, now we have to go wireless, we have to go nearby, we have to use Bluetooth. So Google has an API called the Nearby API, and this allows you to talk device to device directly without requiring a server in the middle. So there's two forms of messaging in the Nearby API. There's Nearby Messages, which is kind of a peer-to-peer pub sub. So you have one device broadcasting information and another device, or any number of other devices, receiving that. You can think of this as kind of a device pairing with a combination of Wi-Fi, Bluetooth, and near ultrasonic audio. Basically, it figures out where the other devices are and how to communicate with them. And then you exchange a data payload. Now, this does require an internet connection. Both of the devices need to be connected to the internet so they can exchange a payload. There's a second protocol called Nearby Connections. Nearby Connections is a little more sophisticated. It's peer-to-peer networking, direct, no internet connection required. It's high bandwidth, low latency. So you have a direct data exchange. In fact, you're streaming data. It's not just a payload. You can actually talk back and forth wirelessly between Android and iOS devices. So I used Nearby Messaging because the API is a little bit simpler. I'll show you that. I also have an implementation for Nearby Connections, and it's far more complicated, and I can't get into the code here. But in order to get a message from one device to another wirelessly without having an existing connection to Firebase, all you have to do is set up a strategy. One device has to broadcast. So we're setting it up to broadcast, and we're creating publish options with that strategy. Oops, sorry. Go back. I'm lost. Okay, here we go. So we're gonna set up some publish options, and all we're gonna do is set a strategy in there, build the publish options, and create a Nearby Messaging client, and define a message. And this message is just like a hello world message. And then we'll publish, and that's it. The device is now publishing. It's effectively trying to tell the world, here's something you need to know. What I'm gonna do is broadcast my authentication token that way. Then on the subscriber side, I can do the exact same thing, except I'm discovering. I'm not publishing, I'm discovering. It's the same thing. You create subscribe options, you set your strategy, there's a callback, and then you can create a Nearby client. Again, client and server, or publisher and subscriber, are almost exactly the same code, except here you have a listener on the subscriber side, and that listener will get invoked when it receives the message. So that's how you can transmit this authentication ID from the app to the device so it can authenticate directly and read and write Firebase. Let's see. So, I forgot what this slide does. So, okay, once a token has been received, and it's in the token variable. So once the token's been received in the Android thing, what I can do is create a Google auth provider credential using that token, and then I can sign in with it. And when that's successful, then I know who the user is. So I basically completed the loop. Now the Android thing can act as if it was me, if I'm the homeowner, which is good, because now I don't have to worry about authentication. It authenticates for me. Okay. Now that was Nearby Messaging. There's also Nearby Connections, which is far more complicated. I'm not going to go over all this. There's code in the GitHub repo, and there's a link at the end. So This is the whole system diagram, and what we did with nearby connections is we added this sort of outer loop. We did a direct share between the phone and the device. Okay, so that's the whole system diagram. But now, what can be improved here? What can we do to make this better? Well, this project needs some code cleanup. It needs better UIs. This was a hackathon project, let's be honest. Hackathon projects are never pretty. If you wanted to productize this, you would have to do a lot of extra work. This is only good for hobbyists. If you're building your own doorbell, this is fine. If you wanted to productize it, you'd have to put a lot more effort into making sure that Firebase is locked down, that every user has their own sort of isolated space. It's going to be a fair amount of work. You can't expect a typical customer to just set up Firebase on their own, right? If you bought this new doorbell and you open the box and the first thing in the instructions said, hey, go create a Firebase account, that's a pretty terrible user experience. You'd have to isolate the user from all of that. But you can still use Firebase. You just have to not make the user use Firebase. Unfortunately, there's no way to programmatically create a new project. So you'd have to restructure Firestore and storage to basically do multi-customer tenancy. So every customer would have to be using the same project in this case. So you'd have to reorganize things. You can't use FCM topics anymore, right? I don't want one person's doorbell to rank the entire world of all the customers' apps. You'd have to lock it down and use direct device messaging in this case. Also need better security. I'm actually going to blow through this because I'm running super low on time. By the way, all of these slides I will have online. So if you follow me on Twitter, or I'll get the conference organizers to retweet. Oh, actually, the one interesting thing I do want to point out here is you can also create digital keys. So say you wanted someone you wanted to give them a sheet of paper with a QR code that would unlock the door. So like maybe a service repair person. You don't want them to have to ring the doorbell. You just want to let them in. So you can use digital keys like that to create it, or you could create a guest app that lets people in. You can use Google Cloud Vision APIs for this. That would be a super easy thing to do. Okay. Okay, so that's all I have right now. If you want to look at this code, go to my GitHub. I just published it the other day. It has all the code that you saw here. It's a little bit more long form. If you have any questions for me, I'll be outside. I'll be here all day. If you want to get hands-on experience with Firebase, I'll be doing a code lab later on in the day. If you want to learn even more about Cloud Functions, my coworker Tina, raise your hand. She'll be doing a session on Cloud Functions later. Do you live demo? All right, live demo. All right, thanks everyone.